Maybe we'll close the doors.
Hello. So that's the MPLS working group. It's our only session this time. Welcome. Oh, hang on. I have to log in again. Or maybe
Nick and Tony, I'll be taking minutes, and I welcome if anybody can also help. Just to let you know.
Yeah, I need to log in.
Okay. Thank you, Tarek. This is our note well. If you haven't seen this before, several times this week, something's wrong. This basically says if you're here, you're participating in agreement with all of the IETF policies, and you're going to behave yourself. No blue sheet because you should be logged in on Meet Echo. The Zulip link is here. Minutes we've just talked about. The agenda is published. Materials are also published through the data tracker. We have a wiki that we actually do try to maintain. And we also have a GitHub, but I don't think there's too much going on there right now. Here's our agenda. Are there any comments or complaints about the agenda? This is page 1. And page 2. All right, if there's no bashing of the agenda, then the next thing up is to talk about documents. We had one errata this period. This is the somewhat simple explanation of it. Any comments on that?
Yes, this is Tarek, and I'm a co-author of the RFC 8960. We initiated, we actually studied this errata and amongst authors, and we're suggesting a way out, and we're working this out with the AD. It can be that we accept this errata, or we open a new errata with a suggested change to the text.
Yes, Jim, I think I already closed it, actually. So I think it's done.
Okay, thank you.
Yep.
All right.
Okay, no liaison statements. And a bunch of new RFCs. We've been busy. And we have lots of docs still in the RFC editor queue. We're moving faster than the RFC editor does. And one still in the ISG. We have several new working group docs. The MNA IOM draft that was accepted and combined and accepted. Let's see, we still have the PSD draft that's still working. And then MPLS stamp pseudowire. We have lots of updates on the ISD document and on MLDB Yang. And don't have too much else in the queue right now. And no new individual documents. Have we run out of ideas? Here are the list of long individual docs that we have not accepted yet. Okay, that's all of our documents. Any comments or questions? Okay, that concludes our agenda bashing and status update. Let's jump into our first presentation. LSP ping and trace route, please.
Are you able to share?
I'm trying.
It says all slots for the week are already taken.
Yeah. Thank you.
That might even work.
Doesn't work. Okay. Hello, everyone. It's Xiaomin speaking. This presentation is on SPPing trace route for enabled in-situ OEM capabilities. The draft for IOM over MPLS encapsulation has been adopted by MPLS working group recently. As specified in this working group draft, MNA can be used to support some IOM option types, including IOM pre-allocated trace option type, IOM proof of transit, a POT option type, IOM edge-to-edge option type, and IOM DEX option type. It's worth to mention that there's an editor's cue in this working group draft. It says IPv6 option is not supported for HBH IOM incremental trace option type. Similarly, MPLS network action is also not supported for HBH IOM incremental trace option type. We also need to take this into consideration in our draft for the IOM capabilities acquisition. Another point is that whether IOM POT option type needs to be supported by MNA is still an open question. As we know, about several years ago, in SFC working group, there's some heated discussion on the IOM POT option type supported in SFC networks. And there was a security concern about this option type. When the IOM POT option type is put to the data packet, whether it's security enough to be used. So it is still not decided for MNA if this kind of option type need to be supported. This is a recap of this draft. This draft defines SPPing extensions to achieve IOM capabilities discovery in MPLS networks. This draft is a companion document of SAVC 9359. It uses RFC 8029 as basis. And for this query mechanism, 5 IOM capabilities sub-TOVs are defined. They are pre-allocated tracing capabilities, proof of transit capabilities, edge-to-edge capabilities, DEX capabilities, and end of domain. This is the history of this chapter. This chapter was first submitted in October 2022. It's accompanied with another IPPM working group draft. That's IPPM IOM Conf State, which has already been published as RFC 9359. This draft was first presented in MPLS working group at IETF 115. And at that IETF, a significant question was raised. Why not IGP? That's a very good question, I think. So this chapter was presented again at IETF 117 to answer that question. And since then, no further questions or concerns raised. There are some major changes since IETF 117. First, welcome Lo Anderson to join his work as a co-author. We added references to MPLS IOM, MNA IOM, and MPLS MNA framework, and added corresponding descriptions. We also removed one sub-TOV from the IOM capabilities response TOV. That's the IOM incremental tracing capabilities object sub-TOV. As I have already explained, that might not be supported by MNA, so we also removed this kind of the same capabilities object sub-TOV in our draft. We also added examples of the IOM capabilities query TOV to explain how it looks like. And also some editorial changes to improve the readability. So next step, the author's request draft is adopted as a working group document. Because the IOM over MPLS encapsulation draft has already been adopted by MPLS working group. So we think this draft is also maybe to consider adopted. Thank you.
Thank you, Zafar.
Zafar Cisco Systems. I have a question. If you have a path for an LSP and LSP path changes, how you handle that?
This mechanism need to be executed if you want to deploy IOM, because IOM is a function that need to be pre-planned.
Okay.
That's not automatically work.
And then reason for this is that you are trying to discover node capability by using LSP
SVP.
attribute.
Yeah.
And this is why the history of the draft exists, is that these are node capabilities, and ONM is not the tool to discover node capabilities. So you can use management plane to discover node capabilities or IGP, and then you have that data with you. You don't have to bootstrap every time you IONM, every time your LSP path changes. So I think that's my comment. I'm not convinced that this is the right solution.
Do you mean that IGP can be used?
I mean, you are trying to discover node capabilities by using LSP ping, and that's not the use, because you just said that whenever your LSP path changes, you have to reboot, you have to rediscover, and all that thing. So you have an easier way to just get these things from node capabilities. You can get it from management plane, other means, save it with you, and then you have it. This is not, O&M job is not to discover node capabilities.
Okay.
My personal opinion that's not a okay. Rex.
May? Okay, I'm co-author, if I may. Okay, as they're saying, there is no one way to slice the bread. There are other examples where echo request, echo reply is used to discover capabilities. Some system may use it to build the database, and then there was no need to do rediscovery, especially if there change to the LSP, recover RSP is minor. So again, to answer your question, I would say it depends, but I would not really say that, oh, there is no example of echo request, echo reply mechanism being used to discover node capabilities. There are other examples.
If I
So
may.
we're just following that example.
If I may. I mean, if this is a bad precedence, that's way we should stop that, not continue on bad precedence. But let me finish. You said that, oh, you can run this on the fly at the one time and build your database because you have a mesh of LSP. You just do whatever, and then you discover. But what if somebody changes configurations? What if somebody removes it, right?
Okay.
From that. So you're always at the mercy of, this is not attribute, right? You can collect it from management plane, you can collect it from IGP, but you think that you can just scan the whole network and then gather this information, or is the wrong way to do it?
Okay, let me give you an example of using SRM MPLS. With the SRM MPLS, you can design the path the way you want it and really discover capabilities of all systems in the domain very easily once. Okay, I would say that if you believe that this is not appropriate mechanism, please do not imply that something that working group should do or not should not do. Okay, it's your personal opinion. In my opinion, for example, using IGP to flood this node capabilities that don't change a necessary burden on IGP, because this information doesn't change. So why make it persistent in the domain? So it's probably better when it's discovered on demand as needed basis. Okay, but again, we all can have our own individual opinions, and saying that your opinion is more valid than mine, I don't see the point. Thank you.
Okay, I did not say the IGP is the only means. You have other means like management plane, but we can take it offline.
Yes, as we are contribution-driven environment, so if you have another idea, please bring it on. Thank you.
Thank you.
Yes, if you have some other suggestions, please raise it, because we are already received is that IGP, why not IGP? I've already answered that question at IETF 117. And if we need to go through that slides, we can do it offline.
Tarek, go ahead.
Yeah, Tariq Fad with Cisco. I'd like to second what Zafar is, highlighting, and on top of that, maybe if the authors consider the scalability of this approach, you will have many LSPs possibly, multi-point to multi-point, full mesh. You'll be discovering the capability from, different LSPs for the same node. I mean, it'll be redundant information. And it might not scale to the number of LSPs, if you want to do that. So maybe considerations to the scalability of this solution, if you thought about that. Thank you.
Yes, we'll consider that.
Thank you very much. Yes, please. You can do it.
So this is an update on the draft, the individual draft that I've been presenting and discussing. What it addresses is that bootstrapping active performance monitoring session over MPLS LSP environment. So what is a simple two-way active measurement protocol? As I said, it's active protocol. It uses specifically constructed probe messages to conduct performance monitoring, measure one-way packet loss and packet delay. Also, it allows to do detection of packet reordering condition and unexpected duplication. So the base specification and extension documents define the base formats and also a number of extensions. So there are two actors, there are session sender and a session reflector, and the mechanism is echo request, echo reply. So what we propose is those familiar with the bootstrapping BFD session is the mechanism to use LSP ping to bootstrap and stamp session. For simplification, the session can use stamp session identifier, so to simplify the demultiplexing of stamp session. And also, so this is an extendable TOV for LSP ping that can include some sub-TOVs that, for example, can use for controlling reverse path of the session. So thus to improve their value of information being gathered, because as I said, stamp is capable of collecting one way, so that's downstream, and to make the use of the upstream reflected packet, so the sender can inform their session reflector system of which path to use for the reflected packets. So there is a number of mandatory bootstrapping parameters, one of them being stamp session identifier, so that it's based on stamp specification, locally unique for the session sender. So that's a combination of stamp session identifier and the source IP address of the session sender uniquely identifies the stamp session. Please let me know if there are any questions. So as I said, so this proposed extension to LSP ping includes optional sub-TOVs, and some of them could be used reusing their target FAC sub-TOVs defined for TOV type 1, 16, and 21 that specify the FAC for their label to be used in the reverse path, or also it could be used a non-FAC TOV, which is essentially a list, ordered list of labels that specify path for their reflected packet. If there is none sub-TOV in the bootstrapping of stamp session, then it must be interpreted as reverting reflected packet transmitted on path default. So by default, usually it will be IP network. So the idea of establishing is stamp session is that session sender initiates transmits LSP ping that includes this stamp TOV. It receives response, and then it starts sending stamp packets. I will note that in this extension, there is no parameters of the stamp session, so thus we don't intend to identify parameters such as the number of test packets in a session, interval between, and so. So that's to be specified for other management plane means. Well, authors believe that this draft is stable and is ready for working group adoption. And we want to point is that the draft is complementary to other work. So one of them being the draft that being mentioned in the chair's report recently adopted is MPLS stamp or the pseudowire. And also the draft that being worked in a spring working group on stamp extension for the segment routing environment. Okay, please, any questions?
This is Zafar from Cisco. So one question, there is an option to do stateless, so you don't have any state and nothing to discover. Is there a technical reason not to use that option?
Well, of course, there is an option, but we find that if you have stateful, then using this bootstrapping helps you to simplify the demultiplexing and control the environment. Because with the stateless, as pointed in this term, so we have stateful and stateless. So in the stateless, of course, there is no way to associate any specific path for the reflected packet. So thus, it might lead, for example, if you have an environment where you use LSPs or SR-MPLS in both directions, so whether it will be measured with one packet, stamp test session, or with multiple. So it's, again, it's a decision for the operator. We provide the tools. We don't mandate how operators use them.
Yeah, I mean, my point is that we started this for BFD when BFD stateless at the egress was not invented. When you have a stateless, it's much more cleaner to do stateless, and I think it's just
okay.
like,
by stateless, do you?
it's there's the egress.
So by stateless, you refer to SBFD?
SBFD, or in this case, I mean, I know you did work on BFD as well, doing the same thing, but I had the same comment there as well.
Okay.
So
okay. Again, I'm not familiar with the stateless BFD mode. So I'm trying to map it to something that I know about.
What I'm saying is that when you have reflector and you're stateless at the egress, it technically is better to use it. That's all I'm saying. Okay. Thank you.
Okay.
If you want to do something for stateful.
Okay. Asynchronous BFD per RFC 5880 has state on both sides, and each side in synchronous mode independently periodically transmits packets. So that probably is not stateless. So can you help me understand what stateless BFD is?
I'm not talking about stateless BFD here. I'm talking about whenever you have an option to run a stateless sessions for the egress, it is better. Now you want to say, I want to run a stateful at the egress, and I want to bootstrap that. That is what I'm trying to point out.
Okay, it could be that in some environments, stateless remote mode is useful. But if we are doing performance monitoring and we want to do performance measurements in both directions and they like independent one-way directions, so to make use of it, the session reflector needs to know what's the path to choose for the particular STEM session. So if you can demonstrate how that can be achieved in a stateless mode, I'll be interested to learn.
I can discuss with you offline, but why
Okay,
can you
let's
just
discuss it online. Please
yeah,
bring.
why can you run two
Yes.
in each direction, independent?
Yes, please
split
bring the
express?
practical
Thank you.
proposal. Thank you.
David Lamparter, easy question. You use the dynamic port range as an option. I think it's for security. If you could clarify that a little bit, because I can't quite find the rationale behind the dynamic port range in the UDP port.
Yes. Okay. That is not really directly related to this proposal. It's just historical that if we look in the history of active measurement protocols developed, so it comes from the time of the one-way active measurement protocol, OWAMP, and then it was inherited by TWAMP, and because we wanted STEM to be deployable in an environment of a TWAMP, so it's like, sorry for the long history tour. But yes, but actually you're absolutely right. The idea of using destination port numbers from the dynamic range was for the security purpose. So then it will be hard to detect. But then in these protocols, OWAMP and TWAMP, they used TCP-based control plane to negotiate it. And so because STAMP would not have control plane, we decided that if somebody wants to use it, then they can provision it through the management plane or through this.
It might be good to put a little bit of what you just said into the draft.
Okay, thank you for the recommendation. We'll do that, some history digest. Okay, so next, because we can go to the next, because I believe I have to, you have to bear with me. One more presentation. Okay, so you recall it was mentioned that we have now new working group draft, which is a product of merging two drafts that address realization of in situ OEM in MPLS networks. And so these drafts approach this problem from two different MPLS network action mechanisms. One was proposing using in-stack data, and another was advocating for post-stack data. So the new draft merged them. We try to make it really reasonable, clean, so that there is no repetition of why in situ OEM is useful and what it allows us to do. So here's the result. Okay, so thank you for adopting this draft. That's hopefully we can move forward. And that's, as I said, the post-stack data is realizing in situ OEM as defined in RFC 9197. That includes trace options and also some modes. And actually, in the preceding, in the first presentation that Xiaomin shared with you, it went through all these modes. In situ OEM proposes only supporting direct export mode. And direct export mode also obviously can be supported using post-stack data. So please let me know if there are any questions because, okay, there is already a question. Is it a new question? Okay, okay, so thank you. Okay, so so first, this is a format for encapsulating and carrying IAM characteristic information that defines the profile of telemetry data that their supporting IAM node expects to originate. And this is based on the current state, at least to the best of our understanding of current state of TS document. There will be some interesting question, but it will be at the end. So if any questions about this, and again, what we're proposing that this TSD can support pre-allocated mode of trace option, end-to-end, and direct export. So that's how would direct export will look like. So if we use instack data MPLS, then it's a little bit tricky because of some conditions for instack data that we need to maintain backward compatibility. One of them being their S bit must not be used, and then the most significant bit must be set to 1, so that this label stack element entry would not mistaken for a special purpose label. So, but at least what it appears that it's durable, might be it's a little bit awkward, but at the same time, because it might be a lighter version to achieve this functionality, and in some environments, really collecting data in a user packet and use, and as a result, use this resources, customer resources, might not be really feasible option. And again, as you can see that, so the IAM DEX RFC defines the sum fields that might be used for correlating data. They're optional because there are other ways of correlating data, one of them being hybrid two-step that document their specification developed by IPPM working group. Well, you have a question.
So, Loa Anderson, I'm going to discuss encoding a bit because I think it's more tricky when you have described it in the draft. So if you start with the flow ID M&A field, that looks to me like that's as an LSC format D, right? Mm-hmm. It should be a 1 in the first position.
Okay.
Yeah.
I'll update it.
Same for the next one.
Mm-hmm. Yep. Okay.
And then we can look at the IOM trace type M&A. You say that bit 1 until bit 25 minus bit 33 mm-hmm. are the same as in the original DEX draft. And then you mentioned bit 7 in the text. So which bit in that field is bit 7?
Again, I had to really, yes, there was some jumping through the hoop to map these fields to the original RFC 9197. It is not pretty, given conditions, but again, the mapping is possible. So
I agree, the mapping is possible, but the explanation of how you're doing it in the draft is not that okay. Good.
Okay.
I actually sent comments both to you and Rakesh, I think, and you should be able to see what's going after. So
okay, of course.
It's quite a bit of update, mm-hmm. I think.
Okay, we'll work on clarifying this text.
Okay,
Thank you.
Thank you.
Of course. And I'll update their figure to highlight the use of most significant bit and their S bit in this optional fields as well. Yes, I'll follow through. Okay, so now we come to the conclusion. When working on merging these drafts, we realized, and you probably have noticed this discussion on post-tech data draft is, so how, what's the reasonable best way, I don't know if it's a synonym or their antonym, to signal the presence and location of post-tech data M&A that is corresponding to the particular network action. Because currently, as I understand the proposal, it proposes to use p-bit and then ISD option with the offset. So then there is a concern that offset by itself is not sufficient. Because if we point to the offset of the PSD M&A header, then in some cases, well, low capability or not capable nodes might not be able to reach because they have a limited fast forwarding buffer space. So this, even if their M&A header gets in the buffer, because there's so much data, they're out of buffer. So trying to reach it, trying to parse this M&A header will really cause their recycling the processing and thus potentially dropping the packets because cannot forward in line speed. So then there is idea, okay, what if each individual ISD action points to its to the offset of its corresponding PSD block. So thus there is no lookup, and at the same time, so basically it points to the offset of PSD block and the length of this PSD block. So thus a node can really easily conclude. The problem here, what might be, is, at least we envision, that what if when the system has to dispose of M&A, and obviously it must dispose of M&A in combination that already have post-tech header systems like Beer or pseudowire or DetNet, then where's the reference to the PSD header to be disposed? Okay, so probably it's something that we'll continue discussing on another thread that already been active today earlier, but that's something that we came to realize that this document will be affected, and we'll follow whatever modifications will be done to the PSD document. Yes, Torlis.
Thomas Eckert. So I didn't understand why kind of the question whether or not an LSR could inspect all the way into the buffers of the PSD was any different a problem from any of the other M&A, calculations you needed to do, whether the packet you were sending could be inspected on path by all the nodes. Mm-hmm. So I think it's the same problem. Yes, of course, it's going to potentially go deeper, but worst case, we just need, I don't know, more control plane on additional information, how deep we can go in the packet, but that's fairly independent of how we encode it.
Well, yes, I agree with you. We remember that there have been systems that cannot have more than 3 labels. I don't know if they're still being deployed, but at least in the ISD document, we say that, oh, be careful how many, what's the impact of M&A, right? So how it will work on post-tech data, that's a different thing because, again, I think that not that we are over optimistic that PSD can support any combination of MPLS network actions, but it seems that ensuring this mechanism that will allow transit node to really easily find out whether it should spend processing time on accessing this node or there is no hope might be useful. But again, we are raising this question. We are not really proposing one way or another. If the group, if community group believes that this is non-issue, okay, then it's non-issue. But what we are saying that this mechanism of referencing presence of PSD in combination with a post-tech header, that's something that needs to be clarified because in current document, it doesn't seem to be complete.
Right. So for example, if there was ISD some indication of the depth, then the node could see, yeah, I can do it or cannot do it, and the sender will know for every node whether it can, you know, get there or it cannot get there, and determine whether PSD would make something like
again,
that.
so
just saying that, not saying this must be the solution, but just to clarify what. Yeah.
Absolutely, yes. We are just flagging the question. Okay.
Thank you.
Thank you.
Okay, so this is a discussion about MPLS label assignment modes, upstream, downstream assign. I don't have a draft for this because this discussion just got heated up right before the IETF, and chairs allow me to bring this discussion here. So the basic problem is that interpretation of label assignment modes according to RFC 5331, it's causing some confusion in the case of DCB labels. DCB stands for Domain-Wide Common Block. That is introducing RFC 9573. So the DCB labels are very similar to sRGB labels. So I will start with the sRGB labels because people are more familiar with it. And then I'll talk about DCB label situation and I'll bring up two proposals to solve this issue. So according to RFC 5331, the downstream assigned label and upstream assigned label definitions are as follows. Let's say you have upstream LSR, RU, and downstream LSR. They agree to bind label L to a FAC F so that packets can be sent from RU to RD. Now, if this binding was made by the downstream LSR and advertised to our upstream LSR, then it's downstream assigned. In the upstream assigned case, there are two cases of upstream assignments. The first one is that the binding was made by the upstream router and advertised to downstream. Another case is that the binding was made by a third party, say R3, and then advertised to both RU and RD. So that's the definition. RFC also talked about the property of these upstream assigned labels. An upstream assigned label must always be looked up in context-specific label space. It does not talk about downstream assigned labels in this regard, but obviously downstream assigned labels are looked up in the default label folding table. To me, this is a defining property, and I'll come back to that later. So a rhetorical question, are sRGB labels downstream assigned or upstream assigned? So according to that property, that an upstream assigned label must always be looked up in a context-specific label space. And since sRGB labels are installed and looked up in the default LFIB, to me, that they are downstream assigned. RFC 8402 does not explicitly mention it. No. But if someone is going to dig into RFC 5331 and try to follow the definition, it may come to a different conclusion. First, the binding for sRGB label is not made by the downstream ILSR. It is made by a third party, in this case, the operator, or you can say that it's by the router who advertised the SID for prefix, and then advertised to RU and RD. So could one argue that this upstream assigned? But we're not really worried about this because people have taken it for granted, and I say correctly that they are downstream assigned. They are just installed in the default labels table, and the lookup is also down there. But DCB label, now we are facing an issue that we have discussed this in the beer working group. And so the DCB is very much like an sRGB that is identical on all the routers. So basically it's a common block carved out of everybody's default label space. We introduced this new name only because we don't want this to tie to SR. It's even you don't do an SR, the same concept applies. So let's say you have a VPN, and the operator says that I want to use label 100 for this VPN. Identify this as a VPN. I want it to be consistent on all the keys so that I can just install label 100 in the default LFIB, and everybody sends traffic with their label 100, and everybody looks up label 100 in the default label table, and everything will be fine. Now, that part actually applies to unicast as well. But then in the multicast case, the way it works, at least in the MVPN using beer, is that the ingress PE advertises that it is using a particular DCB label, say 100, for some multicast flow, and it sends that package with a label. So that packet arrives on a whole bunch of egress PEs with the same label value 100. So actually, after the advertisement in the control plane, the egress PE will install the label 100 in the default LFIB. And when the package arrives, the lookup is done in the default LFIB, and then they know how to forward traffic. So by design, it's considered as downstream assigned label. However, we took it for granted and didn't mention it explicitly in that RFC. Just like in the sRGB case, nobody cared to mention it's downstream assigned. So now, in the beer case, let's say that that multicast package is encapsulated in a beer header, so that label, that DCB label follows the beer header. In the beer header, there is a field called protocol field. It's like next header. If it's the value of the proto field is 1, it means that according to the beer encapsulation RFC, then that means that 1 means that it's the following label is downstream assigned, and if it's 2, it's upstream assigned. Now, we were doing a pre-production interop testing for this beer feature, and some implementations set the field to 2. Even though we're using the DCB label. So that caused some problem. And surprisingly, well, now it's no longer surprising that if someone just follows the RFC 5331, it's natural for them to conclude that it's an upstream assigned label. But the design, by design of this DCB label, they really should be downstream assigned. So there are some observations here. One is that in the case of DCB or sRGB, a better name would be downstream delegated. You basically delegated a part of your own label space for someone else to assign. But But since all this specification so far has only used upstream, downstream assigned terms, that's where the trouble is. But that is no longer accurate or no longer complete. And more similar problem could appear. So what do we do about it? I thought of two proposals. The first one is that we keep the current terminology of upstream, downstream assign, but make a note that the downstream assign, including a downstream dedicated case. But more importantly, we define the mode not according to who made the assignments, really, but based on where the label is from, where the lookup is to be done. So in the old case, I mean the RFC 5331 case from long time ago, upstream assigned it needs to be looked up in a context-specific table. Downstream assigned case, it looked up in the default LFIB. And even with the extended cases we're talking about, that still holds. So if we simply say that if the label is from RD's default label space and is installed in the default LFIB, and the lookup is going to be done there, then it's downstream assigned. Otherwise, it's upstream assigned. So this does not change the existing semantics and implementations, but it's solved the problem we are facing very nicely. And we don't need to change the specification that references this RFC. Another proposal is the deprecating this RFC. Actually, deprecating RFC is probably too serious a word. Let me take that back. It's actually really stop using this term of upstream, downstream assignments. And then, at least in our case, the beer case, the beer encapsulation RFC, where currently it says that next protocol identifier, one means upstream, one means downstream assigned label, two means the upstream assigned. We change it to one means that the top of stack label following the beer header is to be looked up in the default LFIB, and two means that it is to be looked up in the context-specific LFIB. But the problem with that is there could be many RFCs that need to be updated like this. So I hope I explained the situation. I want to hear what people think here.
Thomas Eckert. So 5331 was written in answer to the use case of 5332, which just happens to unfortunately have my name on it. And that was MLDP, multicast over Ethernet. Downstream was just MLDP over layer 2 unicast. So it's just like unicast, you know, downstream label binding. And upstream was meant if the upstream LSR actually does some layer 2 multicast. And then, of course, the upstream would have to assign the labels because how did you get multiple downstreams on the same layer 2 subnet to agree on one label? So that was the purpose of 5331. So when you folks did DCB, I think there was no consideration how what we already had with 5331 would fit, right? So that's when people started to pick something. So I think we're between doing something pragmatic if it's easier. If you ask me, architecturally, the DCB is a different type of label space, right? Just because you take it out of the global label table, it's not, the labels in the DCB block are not exactly managed like the normal downstream labels, but they're kind of more like global labels. They're kind of pre-allocated so that everybody has consistent information, right? So architecturally, it would be ideal to have a third code point that says global label table, coordinated or so, right? But if implementation-wise, you're all crying out loud and saying, oh no, a third code point. I mean, the beer table has enough free values, right? But if implementation-wise that's inappropriate, then yeah, we'll figure out some other solution that's easier to keep existing implementation. But other than that, I'd say we have, instead of upstream and downstream, we now have a third code point, which is global DCB, however we want to call it, because it's a coordinated assigned label space taken from the default label table.
Well, for that one, so that indeed sRGB or DCB, those are the, even though they are globally managed, but they are still carved out of your default label space. And so let's say that as you have sRGB range 100 to 1000, and that means that label 100 through 1000 in your default label space can no longer be used for other purposes.
Yes,
right.
But what I'm saying is the current semantic of the downstream tag means that every node can, independently of each other, allocate that label for a different semantic. If I look at 5 or 6 different LSR, the label 100, right, has a different semantic on all of them. And that cannot be true for a global label table in the DCB block. They all have to have the same semantic. And that's why I think architecturally it would be cool if this thing in the beer header would say, now the next thing comes from a global label table, right? Which exactly emphasizes that, because the semantic of downstream allocated is just not true. It's just implementation-wise from the same, but that's implementation.
Well, just to clarify, so even though the DCB label was originally designed for a case where you want to give the same label for every router, but it's it does not have to be like that. But that's a detail that in that RFC. But here again, I just want to go back to that point where that's the label is to be looked up in the default LFIP. I think that's the point that I want to emphasize, and that's the basis for my proposal 1. But we can discuss. Yes, I hear your view. Yes.
I mean, it is not downstream. I mean, we can attach kind of global label to the same code point in the IANA registry and write something around that, right? But of course, if it doesn't make a difference to the implementation, which code point we take there, then it would be much easier and nicer to add another code point for that and say that's the right font for DCB labels.
Dr. Lamparter, I have a clarifying, context question. You use the word context specific for upstream assigned labels throughout this. Do we have any situation where this context is or needs something other than the source of the packet or the sender? Like, I think it's always just the sender of the packet, right?
It can be third party. For example, you have
I don't mean where the label is set up from. I mean in the process, like for processing it, the only input that is needed additionally is the sender of the MPLS packet, right? This is not about who allocated the label, it's about how you process it. And I believe that in processing, the only context is the sender that is additionally needed to the label itself, right?
More strictly speaking, it's not the sender, it's really just the outer encapsulation. So the outer encapsulation can either identify the sender or another party. Yeah.
Okay.
Tony Lee. I'll note that we're over time. If people want to bail, that's fine. I'll add to this what I thought I said in the mailing list, call it proposal 3. How about we just ignore the terminology and just do what you want to do? You don't need to spin documents. You don't need to deprecate them. You just need to write down what you want.
Okay, thanks.
Okay, this is Zhenbin, so from Huawei. So yeah, in fact, this is also the issues that's in the interoperability test of the BR MPRs between the Huawei and the Juniper and the Nokia. Yeah, so that's we also had the internal discussion. So regarding this proposal, I have these comments. Can we go back the previous slides? Okay, so proposal 2. Yeah. So in fact, Jeffrey, so that's we had the discussion because that's in the in the beer, this is the RFC, because it says that even for the DCB, this is the label. It can also be the context-specific label space, not only the default label space in the RFC. Because you said that in the RFC, it said that it maybe had the common label space for all the routers in the network. So maybe you have to allocate the DCB label. That is some this router from there, the context-specific label space.
That is actually a detailed situation not related to here. So that another common label space identified by a DCB label. So those the labels from that the third context-based label table, they will still need to be looked up in a context-specific label table. So the value of the protofile should still be set to 2. But it's the DCB, that the label that identifies that the third context-specific label space, that label is a DCB label is in the default label space. We can follow up on that separately.
Yeah, because we have the concern that if we take this the 1 or 2, maybe.
No, this will not cause problem for that situation. We can discuss.
Okay, and the second comment can go to the previous slides. That's regarding this the upstream and the downstream sRGB. Previous slides. Yeah. Okay. Okay. Next. Next. Oh yeah, here. So that's the in fact that's the in our opinion is that when we when I think the RFC the R5331 is defined, or the beer encapsulation when defined that time, because that's we always had this the default label space or the context label space. But after that we have this the DCB or the sRGB. So I think this is not revealed carefully about this the global label or the domain-wide label proposed. After proposed, there's maybe the possible issues. In fact, in our opinion, there's the 2 set concept. One concept is the label space. It can be the context label space or the default label space or the DCB label space. Another set of the concept is the upstream, the downstream. In theory, even for the DCB, it can also be the upstream or the downstream. So I think just because when the RFC, the R5331 when defined is not thinking about this the later the DCB label or the sRGB label. I think the possible way so that's the we need not to modify this the existing RFC, but it's just according to the DCB. Maybe we can define some of this the new code points so that it will not intervene the existing RFC that is only applied to the default label space of the context-specific label space.
So if we don't want to do anything to RFC 5331, that's fine. Then the best solution here to me is that then beer encapsulation RFC, we simply say that value 1 means that the label lookup to be done in the default LFIB. 2 means that it needs to be done in a context-specific label table. I'm fine with that, but this also means that we really should stop using the term of upstream and downstream assign. I can accept that too. It's just I thought if people keep referring to the upstream downstream assign and RFC, this kind of confusion will still continue. But that's fine. We can, at least for the particular problem we are facing, I think I'm fine with the updating the beer encapsulation RFC. I really don't think we need to have another code point 3 for DCB or sRGB, and that's my opinion.
Quickly. So that's the why we propose this the first this comments, but we have this but we later have this in-depth the analysis. If we take this tool, because this when the downstream DCB, if it can be also this context specific label space, maybe it's cause the confused action in the data plane.
To me, it's the data plane is very clear. If you have a 1 and it looks up in the default LFIB, if you 2, the upstream context-specific LFIB, that's very clear, and it goes very well with sRGB and DCB. I don't see that problem, but if you can point out a scenario where this could be a problem, I'm all ears.
Okay, we can later ask colleagues to forward these comments in the main list.
Okay.
So, of course, I mean, as Tony said, just implement whatever you want. It's just, it's getting harder and harder to explain when mistakes have been made, right? And the mistake that was made is that over something like beer, which is a multicast delivery, the intended semantic of downstream, which was defined in 5332, and 5331 is just, the additional details for the upstream. Upstream and downstream had semantics. The semantic of downstream does not make sense over beer because it's a multicast medium, and you can only do from that existing context upstream. So then you folks came and said, hey, upstream is expensive, right? Because it's the context label, and we want to do the global label, which is fine, which is great, but it's new stuff, right? Which is a lot easier to explain if you give it a new name, right? And I mean, so reusing the same code point in the table that says downstream, right, is just, confusing. Of course it works, right? That's not the point. The question is, what is the best compromise between just doing what we want, especially if it's not deployed yet, and something that then doesn't confuse people, right? And that's why I was saying, I mean, we retire the bloody downstream code point in the beer table, and we add a new code point, which is for the global table, right? So, and if you folks say this is more implementation work than we would want to spend, fine. Then implementation takes precedence over architectural sanity.
There's really no architectural insanity here, and we can change the names, but I really don't agree that we should change the code point here.
In the beer header, you mean?
What?
In the beer header, you've basically got that code point that says downstream, and this is not a downstream assigned label. This is, a global assigned label. The DCB is not a downstream assigned label just because it's taken from the global table. That's a different, technically that's a different thing.
Right, so basically where it is assigned and where it is from, it really, whether that it's from the DCB or sRGB block that is actually part of the default label space. That's not, then that is
architecture. The architecture is downstream label meant that multiple nodes can independently assign the same label with different semantic. That's not true for DCB.
I'm not talking about the downstream upstreams and the terminology anymore. I'm just talking about in the beer encapsulation header. Now, where we have said code point 1 and 2, I simply say that code point 1 means that the label to be looked up in the default.
You're trying to avoid having to change the code point in the code by, let's say we're redesignating the existing code point to say it's a global assigned DCB label instead of downstream label, because there even isn't, there is no downstream label semantic that makes sense.
There is no, we don't talk about downstream upstream anymore. We just talk about where you do the lookup. That's it. If it's 1, you do the lookup in the default LFIB. If it's 2, you do the lookup in the context-specific LFIB. That's it.
Okay.
Then say that and you're done.
Well, okay, theoretically, right? So now, I mean, if you think a little bit further about it, the whole distinction is problematic anyhow, because as soon as you start wanting to build something like an ASBR between 2 beer domains where you go decap and encap, right, you're going to have the problem that you may need to have 2 of these global tables anyhow, and you will end up, doing a context lookup, right? So hidden underneath the cover. You're not changing anything on the wire, but as soon as you need 2 instances of beer with this stuff that are separate on the same router, in the hardware you need to do some form of context-based lookup because you're reusing the same space, right? So the whole distinction that we're having in the hardware, right? That is an implementation issue. The fact whether or not that should be exposed as a property in, you know, the registry of the code points, I think that's a red herring.
Sunny Zhang ZTE. In this case, I think that the downstream label is more suitable for it because why we use downstream label? Because we looking for the table for the item we just because we received the label from the local assignments. So we use a downstream label. Why we use upstream label? Just because the received label is not from local assignment. So we must look up the table and with the upstream neighbor. So we think that from this perspective, the downstream label is more suitable for this use case. And this is not only for beer, just for all the use case, the potential use cases. So we think that for the DCB, I think that is no necessary for extra code point. And we think that in my opinion, the downstream assigned label is more suitable for this case. Yeah.
Thank you. Yeah, indeed, really just when you can use the default LFIB, then things become simpler and scales better. That's why DCB concept was introduced. Again, coming back to this thing here, to me, the defining property is that where you do the lookup. And we don't have to argue with the downstream upstream name anymore. We forget about the R3 5331. They are just in the beer encapsulation. We change the meaning of 1 and 2, and it does not break the existing implementations.
Where would you ever do a lookup in the upstream?
What?
Where would you ever do a lookup in the upstream?
If you you could have a situation where your label is indeed allocated from a context-specific table, and in that case, you do use a value 2 so that you can do the lookup in the context-specific LFIB.
No, but I think that's different from saying doing lookup in the, okay, when you say doing lookup in the upstream, it sounds more you're doing lookup in the upstream node. So now you're saying you're doing lookup in the context-specific or in the global table to distinguish that.
Lookup is always on the downstream router.
Yes.
Right. The lookup is always on the downstream router. Downstream router has default LFIBs and have context-specific LFIBs. If you see a value 1, you do your LFIB in the default LFIB. If you see a label 2, you see value 2, you find the specific LFIB for the context, and you do the lookup there.
And I was trying just with my last comment to explain that whether or not you do need a context table is an implementation specific issue, right? So that's architecturally not very meaningful.
David Lamporter, this is also a bit of a response to Turles. To some degree, this is why I asked the question earlier about what is context in the wording here. And I'm not sure I'm willing to accept the domain basically as part of the same what is being talked about here as context, as in this problem that the Turles is describing, where you have a router that is part of 2 domains that each have a global label space, which can then collide, and then you get into this kind of problem. To me, feels like it's a different kind of situation than talking about a context-specific label in the sense of upstream, downstream, or some new terminology. And if this is something that we need to solve here, that is an argument that we need a third type for global label that in most cases does not need context, but sometimes needs context if you are on a device that is in 2 domains that both need this same global label somehow. But I don't think it's useful to mix this in here as part of the same context that is always needed if you have this upstream allocated label in normal function, even if you're not doing this kind of mixing of 2 domains. So to some degree, yes, maybe there is a need for a third type, but I'm seriously wondering if that's really something we need, because to some degree, you could also argue it's implementation specific, how to handle a situation with two domains, and just say the domain is the frame that we operate in, and making this work, that is implementation specific, and it's still either downstream or upstream label, and we keep the terms and function as they are.
So Jeff is proposing to reuse the existing terms, right? And I'm just saying, if we're already wanting to keep the two code points, so not to change any implementation, let's just find the best possible names for them, right? And that's why I was saying that the whole downstream thing doesn't work over beer, so let's call it global or coordinated or whatever we want, right? And that would just, you know, make it semantically more reasonable than trying to say which table it is taken from, right? The semantic is that it needs to be a coordinated, a global assigned label. That was all. Just, I mean, right now we're just talking about semantic or naming the existing code point, not changing it, and so that's what I would propose. You're looking at it from the implementation perspective. I'm looking at from the requirements of how the label has been allocated.
Right. I think Tony's point, as he's made in the memo is about our proposal 3, is basically forget about naming, forget about termination, just follow what's the right thing to do. Right? I think.
Yeah, but I mean, that just means that you're getting interval implementation, then people are confused about the strange terminology, right? So given how you need to write something anyhow, what you're using, you can simply put an explanation in there what it is. Whether or not you want to ask for an update of the term in the beer registry, that's just, you know, one additional IANA ask in the document, right? So.
Right. So to basically in the DC RFC 9573, we would do a errata to say that this label is to be looked up and installed in the default LFIP, and in the beer RFC we say that 1 means to be looked up in the default LFIP, 2 means to be looked up in context-specific LFIP. So those are the solutions that I can see without involving the MPLS or larger discussion here.
Yeah, I mean, basically we can take the entry in the IANA registry for the beer working group and figure out, you know, what type of change, update, a small 2-page RFC they'd like to have, and have the discussion about the terminology there, and whatever they're happy with, we can then go back and put in the, you know, errata here.
Yeah, the reason I brought it here is because I thought this concept upstream downstream assign, this discussion could be helpful here, and we could get input from this working group. But I think we've done this.
Well, as far as interop testing seems to be concerned, it seems if you're using DCB, the right implementation now is to use the quote downstream label, right? And
it's just DCB label value protofill value 1. That's basically
exactly.
Yeah.
All right, thank you very much. We still have 7 minutes left, and we can go open mic. Would anyone like to argue about PSD offsets? Anything else at all? I know you like to argue. Come on. Okay, well, lacking anything further, see you in Madrid. It's a mess. I had to change computers because it's a mess. Okay. We got through. That's all that matters. There's a corner again.
Ich rede noch nicht von spezifischen Bier-Anwendungen.